Alright, so in the previous video we talked about violations caused by insert operations. Now in this video we are going to be looking about the violations caused by deletion and modification operations, right? We talked about in the previous video that operations can be, the updations in the database can be of three types, right? Insert, delete and modify. So we already saw the violations caused by insert operations. Now we are going to look at operations caused by delete and modify operations, right? So let us now talk about delete operation. So what delete operation does is it deletes the tuple, one or more tuples from the relation, right? So what kind of violation, what all constraints out of these four constraints can be violated by the delete operation? Let us look at that. Domain constraint. In case I delete the tuple, delete one tuple or more than one tuple, can it lead to violation of domain constraints? No. Why? Because domain constraint says that the value should belong to the domain, right? So that will already be checked when the tuple is inserted. While we delete it, domain constraint cannot be violated. Okay. So just think about it. In case I delete this tuple, can domain constraint be violated? No, right? Let us now talk about key constraint. Can key constraint be violated? What does key constraint say? That no two tuples in any state of the relation should have same value for the key attributes, right? So can key constraint be violated in case I delete the tuple? We are not adding something into it. So how do we need to check about the key constraint? We don't need to check about key constraint, right? Because what key constraint states that the value of the key attributes need to be unique, right? So in case we are deleting a tuple, it is not violated, right? You can check this out, okay? In case you have any doubt about it, you can delete a tuple and check that out. Look for it yourself. Also tell me about the lighting. If this is natural light, in case you you can tell me if you like this lighting more or the tube one more, okay? So now key constraint is also not violated when we delete a tuple from the relation. Now let us talk about referential integrity constraint. So can referential integrity constraint be violated in case of delete operation? Yes, it can be violated. How? Let us talk about. Let us say I want to delete a tuple from the relation department whose D number is 5. Which is that particular tuple? This particular tuple, right? I want to delete this particular tuple from the relation, right? But this tuple is referenced by another or it may be referenced by another tuple in the employee relation, right? Since there is a referential integrity constraint holding from employee relation to department relation, in case I delete a tuple from this particular relation, then it may lead to violation of referential integrity constraint, as some tuple from the employee relation may refer to this particular tuple. Let us see if this particular deletion of this particular tuple leads to referential integrity constraint violation. Okay, so if we are deleting this particular tuple, we are deleting the department number 5, right? But here, is there any tuple that is referring to this particular tuple? That is the tuple with department number 5? Yes. Two tuples from this relation are referring to this particular tuple having department number 5, right? So in case I delete it, referential integrity constraint will be violated. Why? Because what referential integrity constraint states that if a tuple is referring to some other relation, then it should refer to an existing tuple in that relation. In case this tuple does not exist, then it is not referring to an existing tuple in this relation, then referential integrity constraint is violated, right? And it is logical as well, okay? In case I remove department number 5, then how can an employee work for department number 5 if it is not present? Right, it cannot work. So if in case an employee is working for a department, that department should already be existing in the company, right? So that is how referential integrity constraint can be violated when we are deleting a tuple from a relation, right? So deletion operation can cause violation of referential integrity constraint, okay? Entity integrity. Can entity integrity constraint be violated due to deletion operation? No, because we are just deleting a tuple. What entity integrity constraint states? That the primary key value cannot be null. So it would have already been checked while we were inserting the tuple, right? So again, if I delete the tuple, then referential integrity constraint will not be violated. Only this particular constraint can be violated. Referential integrity constraint violation can occur. Okay, so the only constraint that can be violated when we perform a delete operation on relation is referential integrity constraint, that you need to keep in mind, right? In insertion, all the 4 constraints could be violated. In case of deletion, only referential integrity constraint can be violated, right? So what can we do? What are the steps that we can take to ensure that no constraints are violated, right? So only referential integrity constraints. What steps can we do to make sure that no constraints are violated and it is valid and deletion is valid, right? So let us talk about the steps that we can take. Okay, so the first way of handling this particular or the first method to deal with it, what we are dealing with, we are dealing with the fact that deletion of a tuple can lead to violation of referential integrity constraint, right? So we are talking about how to handle that, right? So the first option is to reject the deletion, right? The same option that we considered while we were insert operations led to the violation of these constraints, right? While insertion was leading to violation of constraint, what was the default action that we took? We rejected the deletion, we rejected the insertion. Similarly, when deletion is causing violation of referential integrity constraint, what option can we take? The first option is reject the deletion, that is, do not accept the deletion. In case I am deleting this particular tuple that is being referenced by some other tuple in some other relation, then I just reject the deletion, and DBMS can say that this cannot be performed because referential integrity constraint is violated, right? Let us now talk about the second option. So the second option is to cascade the deletion. Okay, second option is to cascade the deletion. What does cascading means? In case you are getting problem in understanding any of these options, don't worry, we are shortly going to discuss an example and then you will understand what does all of this mean. Okay, so cascade the deletion means propagating the deletion. Propagating means propagating the change, right? What it means is, in case you are deleting a tuple from this particular relation, right, and it is leading to violation of referential integrity constraint because some other tuples in some other relation are referring to this particular tuple, right? So what you do, you delete those tuples as well, right? In case you are deleting this particular tuple that is referenced by other tuples, delete those tuples as well. What it means is delete this tuple as well as delete these two tuples as well, which are referencing to this particular tuple, right? In case I am trying to delete department number 1 from this particular relation, delete all the tuples that are causing referential integrity constraint violation, that is, delete all the tuples that are referencing to this particular tuple. So what can we delete? So here no tuple is referring to this particular tuple, so no other tuples need to be deleted. So in case we are deleting this particular tuple, that is tuple with D number 4 from the department relation, what we can do is, what we will do as a result of cascading, we will delete this particular tuple as well. Okay, so as a result of cascading, what we do is we delete the original tuple as well as we delete the tuple that are referencing to this particular tuple, right? We deleted the this particular tuple and also we are deleting this particular tuple because this tuple is referring to this particular tuple. That is what is the meaning of cascading, right? Now the third option is to modify the value, modify the referencing attribute value. Modify the referencing attribute value. So in this particular option we have two options. First is set null and the second option is set default. Okay, is it visible? No. Okay, so the third option is, I should write here, modify the referencing attribute value. Set null or set default. Okay. So what does it mean by this particular option? In case I am deleting this particular tuple for the tuples that are referring to this particular tuple, what you do is you modify the value of the referencing attribute. That is, if I delete this particular relation, then if I delete this particular tuple, then which are the tuples that are referring to this particular tuple in this particular relation? This tuple is referring here, right? So what you do, you modify its value. You do not keep it as 4 because this is being deleted. What you do, you set it, either you set it to null or either you set it to some default value. Okay, so default value can be specified while we are specifying or we are defining the relational schema. At that point, default value can be specified. Let us say that default value is 1. So you set this to 1 or you set this to null. Okay, so these are the 3 options or the 3 ways in which we deal with violation of referential integrity constraints in case of delete operation, right? And even a combination of these 3 is possible, right? How? Well, let us say we have 4 relations. First is employee. Now look at this example. Listen to this example very carefully, okay? It is very important and it is easy only, okay? It will make you understand all these things. So we have 4 relations. Employee, department, and one is dependent, okay? One is dependent and one is works on, right? So dependent relation, the same we studied while we were studying ER model, okay? So dependence relation stores data about every employee's dependents, right? So it includes employee social security number and then name of dependent. Okay, I'm not able to write. It is too cold outside. Okay, so it includes the social security number of employee, social security number of employee, name of the dependent, and maybe let us say relationship. Okay, so just including few attributes only. Okay, so these are the this dependent relation stores information about employees' dependents. Okay, and there is one other relation, works on relation, that stores information about the project on which employee is currently working, right? So it includes employee social security number and project number and number of hours it is working on a particular project. Okay, so we have these 4 relations, let us say. Okay, so let us say I want to fire an employee. I want to remove an employee from this particular relation. I am saying delete tuple from employee relation where social security number is 403. Okay, so I want to delete this employee. So what is the meaning of deleting a particular employee? We are firing that particular employee, right? So in case we are firing that this particular employee, then many relations or many tuples from different relations are referring to this particular tuple, right? How? Okay, yeah. So this particular attribute, super social security number, refers to this particular tuple because this employee supervisor is employee with the social security number 403, right? So in case I delete this particular tuple, referential integrity constraint is violated, right? What I mean to say is, I am trying, if this particular employee is fired, what it means that the supervisor of this particular employee is an employee with social security number 403, but that employee is already fired. So how is it possible? Right? Not possible. So what we should do? Should we also delete this particular tuple? Should we use this particular option, cascade the deletion? No, right? In case the supervisor of an employee is fired, what we should do? We should either set this to null or set it to some default value. Let us say null. Currently, it does not have any supervisor, right? So that is the way how we can handle this particular referential integrity constraint violation, right? Also, in case an employee is fired, is it okay to delete the MGRSS? And let us say this particular employee is also a manager of a department, right? So this particular attribute is referring to this particular tuple, right? This particular attribute is also referring to this particular relation, right? So this employee also happens to be a manager of some department. Which department? Department number 4, right? So here again referential integrity constraint is violated. In case fire this employee, how can he or she remain a manager of this particular department? This is not possible, right? So what we should do, we should we delete the department as well? Should we follow this cascade the deletion, or should we reject the deletion? Okay, so what we should do, we should again set this value to some default value or set this to null. Let us say I set this to some other employee's SSN. Let us say I have made this particular employee as the manager of this employee, right? So I have given two examples of this particular option, that is modify the referencing attribute value, right? In case of this particular referential integrity violation and this particular referential integrity violation, right? Now, in case an employee is fired, think logically. Do we still need to keep its data of dependents? No, right? So we do not need to keep the data of its dependents once an employee is fired, right? So what we do, we even delete the data about this employee's dependents. Let us say 403 has two dependents and it has some name and relationship. Okay, so this is also referencing to this particular relation of this particular attribute of this relation, right? So in case this particular employee is fired, what we can do, we can delete even these two tuples, right? So in this case we are following the cascade the deletion option, right? The second case, the next case is works on relation, right? So it stores information about an employee is working on project 403 is working on 204, 403 is working on 321. Let us say this is the project number, right? So this is again referring to this particular attribute, right? So if an employee is fired, we can also delete the information about the projects he or she is working on, right? So this can also be deleted. So in case of when this particular attribute is referring to this, and as a result of this attribute is referring to this, what we did is we set it to default or null, or we modified the referencing attribute value. But in case of dependents and works on relation, what we did is we cascaded the deletion. We even deleted the tuples that referred to the deleted tuple, or the tuple we are trying to delete. I hope you got it right. What in cascading, what it means is we deleted this tuple as well as we deleted the related tuples that are causing the violation of referential integrity constraints, right? So that is how we deal with deletion, right? Rejecting the deletion is not very popular. Mostly what we do is we either specify one of these options, right? Either set cascade the deletion or modify the value to null or to default value, right? So these are more popular options than rejecting the deletion. So that is how we deal with constraint violation in case of deletion. This is how we deal with it. Okay, now let us talk about violation caused by update operations. Okay, sorry, modify or update, you can change the name or you can use them interchangeably. So what is modification? Modification means we need to modify the value of some attribute in some particular tuple or more than one tuples, right? Let us say I want to update the salary of an employee whose SSN is 102 to 28,000, right? So that is an example of modify operation, right? We are trying to update or modify the value of some attribute from some tuple, okay, in some particular relation, right? That is how modification operation is done, right? So what can modification lead to? Which kind of constraint violation can modification lead to? Can it lead to domain constraint violation? Yes. How? Let us say I want to update, I'm trying to update the salary of this employee whose name is let us say I want to update the salary. Okay, so let us say I want to update the value of salary, okay, of this employee whose SSN is 102, right? So I want to update this salary as XXX. So domain constraint is violated, right? Or you can also see updation operation or modification operation as a combination of deletion and insertion operation. How? What is it equivalent to? We can see this operation as we are deleting the previous tuple whose value of salary was 30,000 and inserting a new tuple whose value of salary is 30,000, right? So whatever constraints are violated by insert plus delete operations can be violated by the modification operation. So insertion operation led to the violation of all the 4 constraints. So that's the reason why updation operation would also lead to the violation of all the constraints: domain constraint, key constraint, entity integrity, referential integrity, right? How it can lead to violation of key constraint? Let us say I want to update the value of this particular tuple whose SSN is 403 to, now I want to write the new value as 102. Now key constraint is also violated. Why? Because the value of the key the value of the key attribute is not unique now, right? It is repeated 102 for 2 tuples, right? So it is not permissible, so key constraint is also violated. How can it lead to violation of referential integrity? Same, we can insert a tuple with d number, we can just modify, right? We are modifying, right? So we are modifying, let us say I want to modify the value of this particular tuple with SSN is equal to, what was it earlier? I think 403 was. Okay, so let us say I want to modify the value of this particular tuple whose SSN is 403. I want to update its d number as 30 now. So is 30 present here? No. So what it is leading to? It is leading to violation of referential integrity constraint. So it is also violated. How entity integrity constraint is violated? Same. Let us say I want to update the value of this particular attribute of this particular tuple whose SSN value was 403 to, now I want to update it to null. Then again entity integrity constraint is violated, right? So since update operation is a combination of insert operation and delete operation, so whatever violations are caused by insert and delete will be caused by updation operation or modification operation as well, right? So modification operation leads to violation of all the constraints, right? So we talked about these 3 operations: insert, delete, modify, and the constraint violation it can cause and how to deal with it. Again, the same ways that we used to deal with insertion and deletion operation, their violation, the same ways we will be using in order to deal with the violations caused by modify operations, right? So that's about it. That's about violations caused. With this particular topic is done. And now now in the next video we'll be talking about conversion from ER to relational model, and then we'll move on to normalization maybe, right? So this is it for this video. I hope you liked this and understood from this, and if you do, then please don't forget to press the like button, subscribe to my channel for more such videos. I'll see you in my next one.